So what are bitwise operators? Bitwise operators compares values in binary formats. These operators work on integers. When performing bitwise operators on integers, initially these integers are converted into binary form and then they'll use some comparison. Alright, so let's dig into it with some example. And the bitwise operators are and this symbol was called as binary and binary or and binary XOR and binary complement. This is nothing but the negation, and binary left shift and binary right shift. let's uh, let's get to know first about this binary and. Let's try to create two variables over here. A is equal to 19, B is equal to 18. So we initialized or we created two variables with values 19 and 18. Let's perform a bitwise AND operators on these two variables A and B. So the output was 18. How? So in the background, Python first converts this 19 and 18 into binary format and then performs the AND operation. Let's check what is the binary format of 19 first. How you can able to check that in Python? Simple. We have some function. So the binary format of A, which is nothing but 19, is 10011. Let's also know the binary format of B. Know the binary format of B. Okay. Python compares these two binary formats over here and finds the resultant binary format, and then it converts that binary format into integer. Okay, so how it compares, actually how it performs AND operation with these binary formats. Okay, in case of AND, the resultant value will be 1 if both values are 1. Okay, let's try to understand this with an example. Let's copy this. So how Python performs the AND operation. The resultant value of 1 and 0, I mean the resultant comparison of two digits will be 1 if both digits are 1 in case of AND operation. For example, here 1 and 0 should be 0. Will come from start. 1 and 1 is 1 and 0 and 0 is 0. 0, 1 and 0. Sorry, it was 1 actually. So the resultant value should be 1 only if both comparison values are 1. Otherwise the value should be 0. For example, the both values over here, the both comparison values here are 1, and hence the resultant value was 1 in case of AND. Similarly with 1 and 1 is 1 and 1 and 0, since both are not ones and one value is 1 and one digit is 0, the resultant value should be 0. So initially Python got the result by comparing two binary formats of two integers as this one. So let's try to find out what was integer notation of these binary formats. So you can able to find the integer format of a binary digits by using a function called bin in Python. Bin of this one. Sorry, it's not bin actually. Bin is used to convert the integers into binary formats. If you want to convert the binary format to integers, so you need to use a function called integer, int. Alright, so this is a value of 18 actually. Alright, so this is a value of 18 actually. This is similar with OR operation. In case of OR operation, of course, we are, we got to know about AND operation, and now let's know about this OR operation. So how Python compares two binary formats, two numbers actually. So for 19 and 18, these two are the binary formats, and Python initially compares the binary formats, and the resultant will be a binary. And this binary will be converted into integer. So now we got to know about and let's know about OR. In case of binary OR, the resultant, the result will be 1 if at least one of the bit is 1. For example, previously the result will be 1 only if both values are 1, but in the case of OR, the resultant will be the result will be 1 if at least one of these comparison values was 1. Okay, and now the output will be 1. Since at least one of the two about two values is 1, the value will be 1. 0, since no value is 1, 1, sorry, 1, and at least since at least one of the two comparison values is 1, the value will be 1. So this is the value of R, and now Python converts this binary format to integer. So let's check what was the value of A and R, sorry. So the value should be 19 over here. All right, so this was all about binary OR. And what was about this binary XOR, binary XOR? Okay, XOR. In case of binary XOR, the result will be 1 if at least one bit is 1, but not both will be 1. Uh, when comparing these two values, at least one of the values should be 1. If both the values should be 1, the value should be 0 and the result should be 0. So this is a condition in XOR. Okay, let's deal with it. Since at least, if both should be 1, the value should be 0. 0, 0, 0. If both are 1, the value should be 0. If at least one value should be 1, if at least one value is 1, the resultant value should be 1. So this is a binary format when Python compares two integers 19 and 18. So what is the integer representation of this? A, B is 1. Okay. Let's check bin of 1. Okay. So the binary format of 1 was this one. So now we got to know about binary OR. Similarly with binary complement, in case of binary complement, when you okay, let's initialize another variable. A is equal to 9. So how you negate a value? It's it's nothing but A. So the negation of 9 is nothing but A, and you can also convert this minus 10 to 9 by using another negation, like minus 10 negation back to 9. So this is all about Python complement or Python negation. So what is a left shift? Now we'll learn about left shift. Left shift is nothing but the left value is moved by number of bits left, specified by right value. The left value is moved left by the number of bits specified by right value. For example, let's take A is equal to 100. So what is the binary format of A? It's nothing but 1100 and 100. When we apply left shift operators, left shift operation on this variable A, let's check what was the result of this. Left shift 2. So what is the binary for? So the resultant integer was 400. Let's check the binary format of this 400. So you can able to see that now double one double zero one double zero double one double zero one double zero. So the value, the binary format has moved two digits left, two digits left by adding two digits right. So it has moved left actually. Now let's check about right shift. Let's initialize another variable. All right. Let's apply a right shift operation on this variable. 2. Was that really 25? Okay, let's check it. So initially we need to check what was the binary representation of B. B. Okay, so the binary representation of B was double one double zero one double zero. Let's check. I mean, we have applied the right shift operation on this variable B. So the result was 25. So let's check the binary representation of 25 and see whether those binary representation has been moved two digits right or not. 25. Yes. So double one, double zero, one. This binary digits has moved two digits right by deleting 0, comma 0 and 0. You can able to see the length of this 1, 2, 3, 4, 5, 6, 7, and here the length was only 5. That means it has moved two digits right.